Good morning. For today's class, all I have planned is for us to go through some vocabulary. So what you'll need is you'll need the second page and the third page of your chapter 10 tip chart. And there will be no assignment with this today other than to just take notes with me on your tip chart. All right, so the first term we need to talk about today is what a circle is. Now, if I just randomly ask somebody, hey, what's a circle? A lot of times they'll say, well, first of all, they pause and they think, because how do you describe that really? And so a lot of people will say it's just a round thing. Well, we kind of run into the problem that we ran into when we defined a line a long time ago. One of the first things we did in August, actually, is define what they call the undefinable terms of geometry, the undefined terms of geometry. And it's a little hard to define something that doesn't really fit into a class of other things. So here's what a circle is. A circle, like a line, is a collection of points. So we learned in August that a line is just a set of points that are all in a row and it keeps going infinitely. Well, a circle is kind of like that. It is also a collection of points, but it's a collection of points that are placed around a central point, and not just placed around it, but placed around a central point at the exact same distance away from that central point. So we need a center point. I'm going to mark it like this. This is called a safety compass. These are pretty cool. You can order them online. There are some pencil holes right here, and so I'm going to mark one. That's what I'm using as my distance. So this is the distance that I'm choosing. That's my center. This is the distance. And then if I just move this and use that same distance and mark that distance a bunch of times away from the center of the circle, so same distance away from the center, and if I just keep doing that, I get this collection of points that are all the same distance away from the center, and it forms this circle. So it's easier to just draw it as if that collection of points joins together like that. Now, from our lesson on points a long time ago, we know that points don't have any width, so they don't really crowd each other, and they don't really join like this. But there's so many, there's infinitely many, that theoretically we can say that it's joined together like that. Okay, so that's what a circle is. It's a collection of points that are all equidistant from a center point. So, a collection or set of points that are equidistant from a center point. So when you name a circle, you name it by that center point. So I'm going to call this point C right here. And to name this circle, you name it circle C. And when you put the circle symbol, make sure you put a dot in it, because if you don't, it looks like it says OC. And that means the length of a segment if you had OC. So make sure you put a dot in there, because that's the symbol for a circle. Okay, next term. Next term is a chord. A chord is a segment, and it's a segment with both endpoints on a circle. It's a segment with both endpoints on a circle. So a chord would look something like that. I'm going to call this A and B. Segment AB is a chord. It's a segment with both endpoints on a circle. Now, a diameter and radius you probably already know. You would have learned those in an earlier math class. A diameter is a chord. Now, when you first learn diameter, chances are they taught you diameter without teaching you what a chord is. So they may have just said that a diameter is a segment, because a chord is a segment. But now that we know what a chord is, we say that a diameter is a chord. It's a chord that contains or passes through, that contains the center of the circle. So we need the center. Now when you draw the center here, just make sure you don't just slap a point in there. Try to find it. Try to find what would be exactly in the middle. I know that's a little hard to do, just eyeballing it. If you had one of these circle makers, then you always mark the center first so you know exactly where it is before you draw your circle. But here we're just going to eyeball it. And a diameter is a chord, which is a segment with both endpoints on the circle. It just happens to pass through the center like this. Now, you still name it with just those endpoints. Even though it passes through the center, you still name it with just A and B. So segment AB is a diameter. Okay, a radius is a segment. It is not a chord, and you'll see why. It's a segment with one endpoint at the center, one endpoint at the center, and one endpoint, or you can say the other endpoint, on the circle. A segment with one endpoint at the center and one endpoint on the circle. So one endpoint is at the center, and the other endpoint is on the circle. So here is a radius. I'm going to call that C for center. I'm going to call this A. Segment CA is a radius. Now, people confuse these two things. They just forget which word goes with which thing. It's not that it's hard, it's just they forget which word is which. So I don't know if this helps, but the shorter word, when you look at radius and diameter, radius is shorter, is the shorter segment. And the longer word, diameter, is the longer segment. So maybe that helps. And if you can think of another way to remember which one is which, then that would be very helpful, because people confuse them and they forget which one's which. There's a relationship between these. A diameter is twice the radius, which makes the radius half the diameter. So the moral of that story is, if you know one, you know the other. So a lot of times a formula will call for diameter and you have radius. So you just need to double it. And sometimes it'll call for radius and you have diameter. So you need to half it. Okay, next one, congruent circles. So all circles are the same shape. All circles are similar. But to be congruent, they have to have the same radius. So congruent circles are circles that have congruent radii. That have congruent radii. This is the plural of radius. Some people pronounce it radii. So if this radius were the same, let's say it's 1 centimeter, then they would be congruent circles, because it's that same distance away from the center, which makes them the same size. Okay, central angle. We talked about this one with a polygon. So now we're just talking about that same concept with a circle. A central angle is an angle, of course, formed by two radii. And the vertex of the angle is the center of the circle. The vertex of the angle is the center of the circle. So you just draw two radii. So the difference between a central angle of a circle And the central angle of a polygon is that in a polygon, it had to, the two radii had to be consecutive. They had to connect two vertices that are right next to each other like that. Where in a circle, it can be any two radii. Because there are infinitely many of them. Like that. I'm going to call that C. I'm going to call this A and B. Angle ACB is a central angle. And you can tell because this is the center. That middle letter is the vertex, and it's the center of the circle. Okay, minor arc and major arc. Actually, these next three go together. Minor arc, major arc, and semicircle. I have decided to move the arc material into the chapter on circles. I do think you need to know how to name one, but I just won't go into too much detail about what arcs actually are until we get to the chapter on circles. So I decided to move lesson 10.6 into the circle chapter. So a minor arc. First of all, an arc. An arc is just part of a circle between 2 points. Part of a circle between two of the points. A minor arc is small. It's less than 180 degrees. I mean small in measure, so less than 180 degrees. Okay, so here's what an arc is. If you pick out 2 points, let's call this point A and this point B, then it basically separated the circle into parts. This part right here, and then this part out here. Well, both of those are arcs. Arcs are just parts of circles. So that's an arc. And you name it like this. You name it like with a little umbrella thing. Like that. And you read that arc AB. So if you see that symbol, don't go straight from A to B across like that. That would be a chord. You stay on the circle. It curves. That's why the symbol curves. So that is a minor arc. A major arc is also part of a circle between 2 points. Part of a circle between 2 points. But this time it's greater than 180 degrees. Greater than 180 degrees. Okay, so if I mark those same 2 points, A and B, I'm not talking, when I talk about a major arc, I'm not talking about this little one here. I'm talking about this outer one here. Now, a problem arose back in the day when mathematicians were corresponding about this stuff. They were naming both of them arc AB, and they got confused because it wasn't clear in the correspondence what they were talking about, which one. So then they started saying minor arc AB to indicate this one, and then major arc AB to indicate that one. And then somebody along the way got a little lazy and got tired of writing minor and major, so they decided that to name a major one, you would just pick any other point on this arc, so any other point you want. I pick that one, put D, it could be one down here, it doesn't matter. And they would name the major arc with 3 letters. It still starts at A, it still ends at B, but they would name a point that it passes through. So, arc A, D, oops, A, then D, then B is a major arc. So if you see it named with 3 letters, that's major. And this is the beginning, this is the end, this is a point that it passes through. That curvy symbol arc means stay on the circle. Don't go across to D and then across to B. That makes an angle. We're staying on the circle, so it makes an arc. Okay, so we have one that's less than 180. We have one that's greater than 180. So the only thing that leaves is one that's exactly 180. That is called a semicircle. So a semicircle is an arc that measures exactly 180 degrees. It is half the circle. So to have a semicircle, you have to know where that center is, and you have to know where there's a diameter. See, to make exactly half the circle, you would need to know the placement of a diameter. Oops, that was a little too high. So there's a diameter, and that gave us endpoints to block off or to separate off a semicircle. So here's a semicircle. Some people pronounce it semicircle. So there's a semicircle. Now, if I name it AB, you don't know if I'm talking about the top semicircle or the bottom semicircle. Not that it matters because they're both 180 degrees, but I guess there is probably a context where you would need to know which one. So they decided that they would name semicircles like major arcs. So I'm going to put a D right there. Arc ADB is a semicircle. So on a quiz or a test or something, if I say name a semicircle, just remember to name it with 3 letters like a major arc. Let's see, adjacent arcs. Adjacent arcs are just next door neighbor arcs. Just like adjacent angles are joined, adjacent arcs are joined. So adjacent arcs are like that. They are arcs that share an endpoint. Arcs that share an endpoint. So I'm going to call this A and B and D, arc AB and arc BD. See, they share endpoint B, are adjacent. Just means they're joined. When I wrote this tip chart, I accidentally switched these 2 drawings, and I fixed it later, so the one you printed may have been fixed, it may not, but this should be in here. This is a picture of concentric circles. This means with center. So what concentric circles are circles that share a center, like a bullseye. So this center is the center of the little circle, and this center is the center of the bigger circle. We are going to skip arc length because that is definitely moved to the circle chapter. So don't lose this tip chart. When we get back to the, when we move on to the circle chapter, we're going to need this. We're going to need to come back to that. Okay, sector of a circle. A sector of a circle is basically a slice. So here's a sector of a circle. And this is why I had to define arc for you. Even though we're moving arcs to the circle chapter, this is why you have to know what an arc is. So a sector is a region bounded by 2 radii and their intercepted arc. So here's a radius, and this right here is their intercepted arc. Intercepted, basically it's the arc that those 2 radii catch, for lack of a better word. And those are the boundaries, because this region is bounded by those 2 radii and that arc, and you get this region. So basically it's a slice. A slice. And then segment of a circle is also a region bounded by, this time, by a chord and its arc. So if you draw a chord, that chord separates off an arc. This is called the arc of the chord. That's the arc of that chord. Well, that is called a segment of a circle. So that is a sector, and that is a segment. And the reason we need to know that is because we're in the area chapter. And so we're going to be finding the areas of these things, of this sector and this segment. Okay, the last thing I want to talk about, I think I'm going to save this one till the day we do geometric probability, which will be the 2 lessons from now. So we're saving that one for the circle chapter. Don't lose this tip chart. We're saving this one for geometric probability day, and that completes it. Okay. So that's all for today. It's just vocabulary, and now you'll have the words that you need to know for the next 2 lessons on area. All right, y'all have a great day. No homework on this one today. Bye.